Right, good evening all. I'm Tab Binding and I'm your programme manager. So some of you are getting used to seeing me now. This is Riverside Sunderland University Design Challenge. And this is week 3 of a 4-week webinar series that runs alongside that University Design Challenge. I work for TRADA and the Timber Trade Federation, and we're bringing this to you along with our partners, Moby and Sunderland City Council. As I said, this is week 3, and we're talking about materials and carbon emissions. And tonight we got fabric first, tomorrow it's health and well-being, Thursday it's timber challenges, and Friday open house. And this is the competition. Sunderland City Council want to build 1,000 homes, and they want them to be carbon neutral. This is the site, the Vaux site next to the river. And this is what we want the participants to look at. 100 new homes on this particular site, but 1 3-bedroom family home to design, engineer and detail. Which is why tonight's speakers are going to be so essential to your the way you think about your designs, because we're talking about fabric first. And with that, Mark, I would like to hand over to our chair, Mark Siddle.
Thank you very much, Tab. It's a pleasure to be here again, having had the privilege last week as well. Yes, so welcome everybody. And well, first of all, I'm just going to throw a spanner in the works. We often in the construction industry, we talk of fabric first, but really it should be fabric second, because we should be thinking about health and well-being and therefore ventilation first. But of course, to deliver health and well-being, that also means having suitable surfaces and getting the fabric right. So it's not, we've got to get priorities in the sort of sweet spot, should we say. So with that point made, I think that it's my great privilege and opportunity to introduce you to Sarah Lewis, who I've known for probably a decade now, maybe more. Sarah's come a long way and is a associate director at Hamson, Barron Smith, and has written a fantastic book on PHPP, and is today going to be talking about value engineering and optimizing design for energy efficiency. And I think that I'm going to just give a couple more minutes to each individual person, or a moment or two as they conclude their presentation. So that's enough of me for now. I'm going to hand over to Sarah, who will be able to fill you in with a bit more context and talk about value engineering and optimizing design for efficiency.
Excellent. So hopefully you can all see my slides and hear my voice now. Excellent. So hello, as Mark said, I'm Sarah Lewis, architect and sustainability consultant at Hamson Barron Smith. I've broken this presentation, it's just a 15-minute presentation, but I've broken up into 3 sections today. And the first section, I will be covering just a few moments or so, giving you a quick overview of what we mean when we say zero carbon. And this is important to clarify when we're talking about how best to optimize our designs for energy efficiency. Then I'll briefly summarize where we are now and where we need to get to. And finally, the main section of the presentation, the final 3rd section, will be a practical look at how we deliver energy efficient projects to meet our zero carbon commitments. And I love presenting on this topic, and I could talk to you all night, but I have promised to keep the presentation to time as there's lots of great speakers to come after me. So let's get started. What is zero carbon? So carbon in buildings is produced in 2 ways. Firstly, from construction and the ongoing maintenance, which we call embodied carbon. And secondly, from the energy consumed during its lifetime of use, which we call operational carbon. So let's see that in a graph. A number of the graphs I'm using today came from the Letty guide, which I recommend you refer to if you have not already. As you can see from this graph, the pink is the embodied carbon, and that's mainly a concern during the construction phase of a project and again at demolition, while the yellow is the operational carbon, and that is produced every year the building is in use. And it's important now that we can understand what the kind of overall impact each of these types of carbon has to the overall carbon pie of a building. So in a general building built to standard standard building regulations, the most significant carbon culprit is operational carbon, quite significantly so. So that's the yellow. So this is really in the first instance where we need to focus our attention if we're looking for big carbon wins. We can significantly reduce this operational carbon by adopting a low energy build standard, such as Passive House, which I'm going to cover later on. Our key strategy for achieving lower zero carbon ambitions, therefore, is to reduce the operational energy demand to as low a level as possible through adopting a fabric first approach. So we really need to focus on reduced energy demand by design for all of our projects. So once you've tackled that big operational carbon slice of the pie, suddenly the embodied carbon takes up a much bigger slice of our pie. So we do always have to keep this under review in all of our decision making. But as I've shown, operational carbon really is our main focus. And for developments, when we use the term net zero, this almost always refers to net sort of operational energy. So net zero energy in operation. So it's defined as all the regulated and unregulated energy, and it must be offset then by renewable energy. And we like, where possible, to do that on site, although that's not always possible. The diagram to the right here just shows what energy is classed as regulated and unregulated. But the important thing to realize is that we calculate and include all of those in our calculations. So basically, this is what we aim for. And this should be the aspiration for all projects, with the option to invest in off-site renewables where it's not practical to generate all of the energy on site. But lots of clients, as the client for this design project, they want to have a true zero carbon development. So it's really trying to do that offsetting of the energy demands on site. So to go back just for a very brief moment and set all of this within its UK-wide context and look to see where we should have been by now, the 2016 zero carbon standard was abandoned, but it would have required all projects from 2016 to find that energy balance I showed on the last slide. These next two slides are from the Passive House Trust, and this one shows that scrapping that 2016 carbon standard has resulted in a complete flatline in terms of energy performance data when we look at all of our energy performance certificates lodged for new homes in the last decade. So we have in effect lost a decade during which we did very little to improve our carbon emissions from buildings, which you can clearly see in this slide, which shows the UK greenhouse gas emissions from buildings over the same period. Now, we do know where we need to be, and the government has legislated to that effect with a requirement to be zero carbon by 2050, but we already need to be on a very steep downward trend. And as you can see from the previous graphs, we've not even started our journey in the built environment in many ways. I mean, there are lots of good practices out there doing good work, but as a general trend, we need to do so much more. So the time is now. The graph gets steeper every day, which is, why this project that we're talking about today is so important and why we were so keen to present as part of this design challenge competition. So another big issue we have is the performance gap. And we see headlines in the news all the time about poorly performing homes, which, it's kind of what Mark was saying about the most important thing is creating healthy environments. And that's what we need to be doing. Buildings often are using up to 5 times as much energy as designed. And they're creating these really uncomfortable and unhealthy environments, which is, a terrible situation to be in. And the systems often are just way too complicated that we put in for people to control, and they're becoming increasingly expensive to maintain. And there's a sort of tangible lack of quality control on site and through the design process. Now, I do apologize for being so doom and gloom, and I promise to be much more upbeat for the remainder of the presentation, as there are lots of exciting and inspiring developments all over the country. And we do have tried and tested methodologies to address these systemic problems. But as we say, now is no time to reinvent the wheel. We do not have time. So this graph is from a housing development I'll present a little bit later on, and it was one we completed back in 2016. The green bar on the graph was the predicted energy demand, and the red is the actual monitored demand in use. And as you can see, there is excellent correlation. This was the total heating energy demand for a 3-bed semi-detached home built to the Passive House standard. And it used less than £40 a year for the space heating. We actually had residents called up by their energy providers to ask why their homes were not in use. So It's an unusually low energy demand, but there's no reason why it should be unusual. So the Passive House Standard, just to briefly explain the term, is an internationally recognized as a leading low energy build standard for new builds and renovation projects, and it's successfully implemented worldwide. It's a voluntary standard and it reduces the building's ecological footprint, resulting in ultra low energy, healthy, comfortable buildings that require very little energy for space heating or cooling. And at its core, it really is a rigorous comfort standard, going back to what Mark was saying about health and comfort. And it ensures a building is free from drafts, free from cold spots, free from excessive overheating, and it's provided with a constant supply of fresh, clean, filtered air throughout the day. And it does so with a minimum amount of energy. As you can see from this graph, the total energy demand for heating and hot water in a passive house is a fraction of that of a standard new build home. And therefore, this standard gives us the best shot at being able to deliver net zero energy developments. So now I'm going to cover, this is the bulk of the presentation. So I'm just going to cover some of the key ways in which we optimize design for zero carbon sites built to the Passive House standard. So firstly, we optimize the orientation. This is a site plan from Carrabrick Meadow, which I'll use as a kind of reference project throughout the remainder of this presentation. An optimal orientation will have the homes principally on a kind of east-west axis, which maximizes the opportunity for south-facing windows, which can enjoy lots of free heat in the winter and can be pretty easily shaded in the summer. And we try to keep east and west windows to a minimum, as these contribute more to overheating problems. This image is again from the Letty Guide, and it shows how changing a building's orientation from a kind of optimal south principal window orientation to, say, a northerly orientation almost doubles the energy demand. So that's the kind of optimal option. As you can see, it goes up as you go across the page. And you don't need to see this as a limitation to design and creativity. Carrabrick Meadow won a national RIBA design award. So you should feel empowered by your knowledge of what an optimal orientation is and make, careful adjustments and judgments when you move away from that. For example, creating special house types when you turn a corner, or creating special architectural statements across the site at various points, or adding interest and joy to the designs. That should all be part of the process, but it should be done with the knowledge of how to create an overall low energy development site. So this is a zero carbon site we designed for a client. So in this site, we weren't only looking at reducing the energy demand, we were also looking at optimizing the design for energy generation. So in this project, we were looking at PV panels on the roofs. So roofs had to be orientated to support that. But it was pretty easy to accommodate because our passive house designs had already prioritized that main east-west access through the site with the south-facing blocks and terraces. So again, with a real sort of focus on design quality, but within the parameters of an optimized layout. So again, not trying to limit anyone's creativity. You need to utilize all the creative energy you've got, but just do it in an informed way. So optimizing the form factor is equally important. This diagram shows pictorially how the shape of a building affects its efficiency. So the form factor is very easy to calculate. It's just the total heat loss area, so the envelope of the building, divided by the internal floor area. And you want this number to be as low as possible. So smaller buildings will inherently have a higher form factor. So you have to work even harder with small buildings to make them efficient. This slide simply shows 4 small buildings with identical floor areas. But as you can see, the design decisions on the shape of the building envelope have a huge impact on how big the heat loss area is, so how much heat's lost through the envelope. The shape gets gradually less efficient as you move from left to right, with the shape on the far right having almost twice the form factor, so almost twice the heat loss through the building envelope, which would mean that you'd need twice the insulation to get the same performance, which is got a big impact on carbon cost. When people say it's not affordable to have a zero carbon site, that often means the design just was never optimized to be a zero carbon design. So again, this image is from the Letty Guide, and it helps to highlight the challenge of small homes. You can see a bungalow just inherently will have a higher form factor than, say, a mid-terraced house or a mid-floor apartment. So basically what we're saying is the more homes that you can kind of group together into a block, as a general rule of thumb, the more efficient the design will be. And as noted on this slide, you can half the form factor, half the insulation if you half the form factor. So it has a big impact on material and costs. So Finally, a high form factor often means that you have a very complicated build envelope shape, which has been usually driven by the design of the building, and it will cause you extra problems when it comes to working up all of your building details. So, it's difficult to get rid of thermal bridging in a complex envelope, and you've got the additional problem of having a poor form factor. Okay, so our passive house approach, requires us, first of all, to completely wrap the building up with insulation, which is a bit like giving the building a nice cozy woolly jumper to wear on a cold day, and it helps to keep all that nice warm air inside the building when it's chilly outside. Then we need to really focus on eliminating thermally weak points where the heat can leak out, so it's often where structure comes together. And as I mentioned, to make sure the building comfortable in summer, we design sort of solar shading to control the sun's energy and lots of opportunities for natural ventilation through windows. And then to further help keep all that nice warm air inside the building and to make sure it's very comfortable to be in, we also have to give the building a wind and airtight shell, just like a jacket you might wear, and that eliminates all those uncomfortable drafts. And finally, to provide the absolute best in terms of health and well-being, we put in a super efficient unit to bring fresh, filtered air into each living space, which is pre-warmed with heat saved from the air extracted out of secondary spaces such as bathrooms and kitchens. So I'm going to now talk through each of these passive house principles and how we address these at the Carrabrick project. So to form our continuous thermal envelope, we prioritize a number of low carbon and environmental products, such as clay blocks for the main walls, recycled newspaper, insulation in the lofts, and natural lime plasters and renders. Here you can see the clay blocks that were chosen as they had sort of good environmental credentials and would work well with the contractor's supply chain, because the particular contractor was keen to use their supply chain that was used to masonry construction. And as you can see, these particular blocks, they got a very good Green Guide rating. They use 95% less water than traditional block work, and 30% of the material was from alternative or recycled and secondary sources. So we felt like it was a sort of good environmental choice. And then these clay blocks were paired with natural lime plasters and renders to create a fully breathable wall construction, which really optimized internal comfort and health. And here's an example of the recycled newspaper, which we used for the roofs. And that was a sort of timber cassette, which was actually constructed on site. So the thermal bridge-free construction, again, it's so much easier if you have a rational building form, but it's still possible with more complex details. You're just giving yourself more of a challenge. Here's an example of the foundation detail from Carrabrick. And as you can see, the insulation just very easily wraps all the way around that foundation without a break, and that is what is so critical. So draft-free construction, we like to say that airtightness is the sleeping giant of energy efficiency. So you need to have a very robust airtightness strategy. You must be able to basically take a red pen over your drawings to show the airtight layer, and you must be able to do it without lifting the pen off the page. In this particular project, we used taped OSB boards for our internal airtightness on the roof, and we used a natural lime plaster internally as the airtight layer. And attention to detailing is absolutely critical at the sort of on the drawing desk, the architect's work, but also on site, and working with the contractor with sequencing is really critical as well, to make sure that this picture shows some of the airtightness products going in at an early stage, because they needed to be on site installed before some of the superstructure went up. So summer comfort is very important for all of our sites and homes, and you do need to have a robust shading strategy. We like to use fixed shading elements where we can, such as brise soleil, deep window reveals, trees. Where needed, we do sometimes include external sort of Venetian blinds, but as soon as you do introduce those elements of occupant control, you're introducing less control as a design team over how the building will ultimately perform. That's an example of the brise soleil, which are nice fixed elements at Carrabrick, which architecturally I think look really good as well. And that's an example of where we, on some east and west windows, which are much harder to shade, we had to put in some Venetian blinds. But it's always a balance. And this is just to say, do keep window proportions sensible. Again, the Lefty Guide has some good rules of thumb here. It's very tempting to be like, it's a green building, we want free heat, let's have 100% glazed south facades. Not really a good idea, because it creates overheating problems. Carrabrick has about 20% of the south facade glazed, which is about right. And it allows the homes to get the most out of that nice free heat in the winter without overheating in the summer. And then, of course, we have to have our MVHR systems. That's our fresh air, and that is critical to optimize health and well-being for residents. So, key to this project's success and the performance was the simplicity of the design, both the architectural details and the services. The most innovative technology in the building was the MVHR system, and our post-occupancy evaluation showed that not one of the residents reported that the home was difficult to use, with just under half reporting it was easier than a standard home to use and maintain. And most important to us as architects is that the residents enjoy the quality of their new homes, which eliminate fuel poverty, creating comfortable, healthy homes for them and their families. And this is a legacy which we get to leave behind when we aspire to do more. I think you'll get these slides, so I'm going to skip over the quote, but it's just someone talking about how comfortable it was. I've just got a couple of slides which I'll just run through really quickly because I realize I've just gone over the 15 minutes. So I've included this slide just to highlight the importance of understanding your building's energy needs and interrogating these, and then looking to see how you can match it with energy produced on site. So that's something you've just got to do as part of the process, is understand your energy balances. And then, on this particular project that we were looking at, doing a zero carbon project, we were looking at offsetting that with PV. And again, each block individually, actually, we couldn't quite get to work, but as an overall site, we could get the energy balance right. So some optimal roof orientations produced a bit more than that block might need, and another one might underperform. So we did a site-wide strategy, which is, something worth considering. So in addition to the fresh air system like the one we used at Carrabrick, we do tend to now also utilize things like shower wastewater heat recovery, which has developed a lot since we completed Carrabrick, and it's very much a passive technology and does not require regular maintenance. You can get about as much as 60% heat recovery from shower water, which feeds back into the supply water, so that's really good. And then we look at low carbon fossil fuel free solutions, so heat pumps, generally air source or ground source heat pump. So once we've driven down that demand, we're able to supply the small amount of energy that's still required through renewable energy on site. So that creates, really exemplar projects where you're able to achieve that. So I'm just going to finish by summarizing our key sort of design rules for low energy and zero carbon developments. So absolutely top of the list, use rigorous evidence-based comfort and energy standards. Do not try to reinvent the wheel. Remember why we design buildings and always prioritize healthy environments. Make sure every member of the design team understands the importance of simplified systems and reduce energy by design, not by offsetting. And most importantly, we should all be looking to deliver high quality buildings and leave a legacy for our residents and building users, which we can all be proud of. And I'm going to stop there because I'm a couple of minutes over. Thank you very much.
Thank you very much, Sarah. That was a great presentation, a whirlwind tour through everything Passive House there. So that's super. Thank you very much. I'd like to pass over quite quickly now to Nick Boulton from the Northeast Timber Trade Association. And Nick is going to be talking about sustainable timber products, palliative products for the built environment. Nick, over to you.
Thank you very much. Hope you can all hear me. Let's jump into my presentation. Here we go. Okay. So I work for the Timber Trade Federation, and one of our regional associations in the Northeast is supporting this project. So I'm representing them as well. We have quite a number of speakers tonight who will go into detail about specific product areas. So by way of an introduction, I'm planning to give you a bit of a whistle-stop tour about some of the types of wood products that are available in the UK. I thought I'd start though by introducing the Timber Trade Federation. We're a trade association representing timber manufacturers, importers and distributors. We have regional associations throughout the country, including the Northeast Timber Trade Association, who are sponsors of this webinar series. If you're looking for wood and wood products in the Northeast region, then your best place to go is to speak to the experts at the Northeast Timber Trade Association. They have their own website and you can search for a list of their members and source wood products through them. When you're deciding what construction products are most suitable for a particular project, the options can be considered in terms of function, form, appearance and cost. Speakers at last week's webinars talked about the function of wood in terms of structural properties, and my fellow speakers tonight are talking about wood in terms of function for specific applications such as insulation, internal and external joinery, decking and cladding. So I'm going to concentrate on the generic forms of wood products that are available for construction and some ideas about how and where they might be used. But first, a very quick word about costs and benefits. The environmental benefits of using wood, I think, are becoming more and more clear to the construction sector. Sequestration during growth outstrips any emissions from harvesting, processing and transporting wood products. In terms of carbon capture, you're talking about a tonne of CO2 per cubic metre of wood. So that's quite a high intake. It's got the lowest embodied energy of mainstream materials, which we've just heard is obviously very important once you address the operational energy. And it's got some of the best thermal insulation properties of mainstream materials. Growing trees in the UK particularly provides a whole variety of ecosystem service benefits. So wood products are renewable, reusable and recyclable. What about the woods that are generally available in the UK? Well, there's some photos there of perhaps the 8 species that are top of the list: pine, spruce, birch, larch, oak, beech, ash and walnut. There are many thousands of wood species that we could potentially use for construction. So don't let anyone curb your imagination. These 8 perhaps are the most easily off the shelf wood products, and they provide a fantastic and sustainable construction solutions. But there are always many other choices of wood species and wood products that as a designer or a buyer you can seek out from your local sawmill or specialist timber supplier. And as I said a few moments ago, one of the best sources for that is to look on the NETA website as to their list of members. As Europeans, the most easily available wood species are those that come from the forests around us. So here in the UK, we're very lucky in that to the north of us, we have the coniferous forests in the Borders, Scotland and Scandinavia, which give us pine, spruce, birch and larch. While to the south of England, Wales and Central Europe are the temperate forests giving us oak, beech, ash and walnut, to name but a few. We can, of course, source wood species from further afield, such as North America, which can provide their own unique taste, their unique take on coniferous and temperate forests. They provide things like oak, ash, maple and cherry, all being top sellers in the UK currently. But we need to remember that cost must always be a consideration, and increasing distance from the source, better visual appearance, greater natural durability, increasing strength are always factors which will increase the relative cost of the wood products that you're buying. So it's about getting a balance between the properties that you need and the cost of products that are available. There are, of course, many ways to try and convey to an audience the variety of wood products that are available. And let me assure you, I could quite happily spend the whole evening painstakingly explaining the difference between block board, lambing board and batten board. But I fear, as you've been good enough to give up your evening, I need to move on. So I'll keep it light and try and give you a bit of a whistle-stop tour of some of the varieties of wood products that we see. If anything takes your interest, then please raise points or questions on the chat and I'll try and address them at the end of my presentation. One critical point I would like to make about wood processing is that absolutely nothing is wasted. The integrated sawmill and manufacturing facilities in both the UK and in Scandinavia fully utilise the wood that is available. Even things like bark and branches are used to generate energy to season and dry the product, making it suitable for the dry construction environments in which most construction products are used. So where do we start in terms of forms of wood products available? Well, in much the same way that a potato is the staple of our kitchen habits, then we could say that perhaps wood products are a staple of our construction habits. So if you have one of these, or in our case, more of these logs, then there are a variety of ways in which these raw materials can be deconstructed to achieve a palette of sustainable wood products. So how can we deconstruct those logs to produce usable wood products? Well, there are quite a number of ways. You can use them whole as structural columns or posts, almost looking at the tree as a log and using it itself. You can cut up the log, and that is to produce what we generally recognise as timber. You can peel a log to produce veneers like sharpening a pencil. You can shred the log or smaller sections of timber to produce flakes, strands or ribbons. We can mash up the log, although it's slightly more complicated than that, to produce individual wood fibres. You can roast, bake or chemically alter the structure of wood products to make it perform in particular ways. You can even press wood to increase its density. And as we're seeing increasingly in the Scandinavian countries, you can even puree wood to extract materials at a chemical level. And I guess you can even pickle it. I know you don't normally pickle potatoes, but go with me on this analogy. So here's our entry-level product, a tree, or once you cut it down, a log. Logs are very useful where your ambition is to build log cabins or specialist log houses like this one. However, looking at the gallery, I can see the smart ones amongst you are already having identified a major problem with our entry-level product, particularly for modern constructions, which is a lack of square edges or corners. Every cloud has a silver lining, and for the wood industry, we simply took our entry-level product and started at a very early stage in man's development to engineer its properties in a wide variety of ways to suit our construction needs. So in this sense, our industry has had a very long period of R&D for the development of a portfolio of wood products, starting from our entry-level tree. However, I can assure you our processing facilities have improved considerably over that time. So looking firstly at deconstructing the log by cutting it or sawing it. This is kind of the basic pattern that would be used at a sawmill to produce usable rectangular sections. The rectangular sections that are produced can be appearance graded on the basis of selecting visual defects that we don't like. And this selects the wood to be most appropriate for visual applications, such as furniture or joinery products that Kevin is going to be talking about in a few moments' time. Or these rectangular sections can be strength graded using a machine or visual technique to produce structural wood, such as C16, C24, TR26, or L grades for glulam. These structural sections can then be combined together in a factory or sawmill to produce larger construction elements. If a saw and finish is a bit rough, then you can run the sections through a planing machine where a set of revolving knives smooth out the surface for PAR, planed all round, or shape sections such as skirtings, architraves, window boards, etc., and other forms of trim. As I said, you can recombine those rectangular sections from the log, and this produces a whole new family of wood products that come under the general heading of engineered wood products. And a lot of the webinars last week were talking about these. Examples of engineered wood products using solid wood elements would be, for instance, glulam beams and posts, which use lamella or elements from 10 mil thick and upwards. The latest product on the block is obviously cross-laminated timber, CLT, which uses sections of wood greater than 40 mil thick to create massive engineered wood elements, creating whole floors, walls or roofs. That, as you saw last week, can truly push the envelope of what architects and engineers have seen as the limits for wood construction. A quick word about lengths in terms of practicality. Most wood is available in lengths from 2.4s up to 5.4 metres in these increments. Those kind of lengths should be easily available off the shelf at a good timber importer or distributors. 6.0s and 6.6 metre lengths may be available from stock, but certainly should be available to order. And for these longer lengths and some of the shorter ones too, you may see an increasing amount of finger jointing. This is where specialist joints are used to combine shorter lengths to create longer ones of higher quality. Don't be afraid of finger jointing, but for structural applications, make sure the wood has the necessary certification for structural finger joints. A quick word about structural sizes. I'm sure you will have seen tables of sizes that are available. These are the most common structural ones that are available in the UK. Again, most of these sizes should be available off the shelf at a good timber merchant. The great advantage of standard structural sizes means that there are standard span tables available, which indicate the clear span between supports, which can be achieved by particular sizes when subject to particular loads. But the beauty of wood is that you can easily cut and shape, so don't let standard sizes curb your imagination either. Another way in which you can deconstruct a log is to peel it, and effectively that's producing veneers by spinning the log against the fixed blade to produce ribbons or veneers. Once you've produced those veneers, then it's a bit like sharpening a pencil, really. If you think when you sharpen a pencil, you'll see ribbons of the pencil coming out. You can then recombine those veneers to produce traditional plywood, or a more resource-efficient laminated veneer lumber, which specifically engineered to maximise the properties for its end use as structurally engineered products. So there's a whole variety of family of products there. They even tried turning spruce veneers into something a bit more innovative, like bathing suits. For some reason, it didn't catch on in the 1950s, but the LVL did, which is good. Another way in which you can deconstruct the log is by shredding it up to produce flakes, strands, or ribbons. These can then be recombined into products that we'd recognise as OSB, orientated strand board. If you want wide, flat, wood-based structural panel products, LSL, laminated strand lumber, which gives you narrow, strong products for things like beams and columns. And then you've got other variants like parallel strand lumber. All of these are different forms of engineered wood products based on strands and flakes. All of them are trying to orientate the flakes so that you get particular structural properties. OSB is quite an amazing product, and we've seen massive growth in that area in recent years. And there are now a huge number of different varieties of OSB, including fire retardant varieties, airtight varieties, moisture resistant varieties, and a whole bunch of other products as well. You can deconstruct the log by reducing it down into individual wood fibres. Generally, that's a physical process, grinding the log or smaller sections of wood down. Once you've produced individual fibres, these can be suspended in water and formed into hardboards, soft boards, or medium boards. These are a family of fibre board products that are really quite innovative to the UK, particularly in terms of rigid and semi-rigid installation boards. These products have been used in Northern Europe for many years, particularly where the climate is quite cold, which perhaps should tell us something. More about these insulation products from Mark in a few moments, I think. The other fibre-based products that are suspended in water are of course, paper products, but that's a whole different industry. Of course, wood fibres can be combined together when dry rather than wet, and you just simply add a little resin to pull those dry fibres together and compress them into perhaps one of our most innovative, but perhaps least photogenic wood products, MDF. The MDF family now has more variety than Ben & Jerry's. Standard, lightweight, emission-free, moisture-resistant, fire-resistant, bendy, exterior, you name it, there's an MDF for it. We've also seen a significant shift towards individual products made from MDF, like skirtings, architraves, and various wood trim being produced. Don't think for 1 minute these are just the boring white painted versions. They also come in a variety of colours, nowadays are even veneer wrapped. However, I'm yet to see a photo of MDF that does not instantly send an audience to sleep, hence the reason why I haven't used one. Most construction professionals know that as the moisture content in wood is reduced, it becomes stronger, more stable and more durable. Taking this process to an extreme levels by heating the wood to over 200 degrees has the effect of altering its chemical structure. And this has the double advantage of making the wood even more stable and more durable. This type of modified wood products is sold under the generic name of thermowood. But there are many commercial brands offering a range of properties and prices. These are particularly suited to cladding and exterior joinery. We believe thermowood still has a lot of development potential while we push the limits of enhanced durability. So I said you can even pickle wood. Well, actually, there are some simple processes that can be applied to wood that significantly change its properties or even alter its basic chemical structure. These range from preservative and fire retardant treatments through to much more innovative processes that alter the wood itself, such as the modified wood products that Richard is talking about later on. These forms of modified wood products are sold under specific brand names depending on the process. If your wood needs preservative treatment to enhance its durability, make sure you specify the right use class appropriate to where the product's going to be used. Janet is going to look at this topic from a decking and cladding perspective shortly, so I won't go into detail, but to suffice to say, the simple message is use class 2 for interior construction products that need protection from raised moisture or perhaps insect attack. Use class 3 for exterior above ground. Use class 4 for ground contact applications. And then to finish up, you can deconstruct the log by pureeing it and turning it into a chemical feedstock. We're increasingly seeing this as a replacement for oil, and it produces a range of materials which previously have only been available from oil-based products. So not really relevant for tonight, but certainly a shape of things to come. Okay, well, that really was a quick rush through wood products. As I said, if you are looking for wood supplies, visit the Northeast Regional Association website or the TTF website. And if you've got any questions, put them on the chat and I'll try and pick them up in a few minutes. Thanks very much.
Thank you, Nick. Over to you, Mark. Whirlwind moving forwards here. So Mark Lynn is here from the Natural Fibre Group, Insulation Group from the ASBP. And Mark will be presenting on natural fibre installation. What, why, where and how. No when in there. I think when is now, isn't it? Yeah, Mark and I first met each other, I think in earnest, down at Larch Corner, that he came round and looked at, and we've got plenty of wood fibre insulation there. The first installation of wood fibre blown insulation in the walls, along with lots of others. So Mark, without further ado, yeah.
Thank you.
15 minutes.
15 minutes. I've come home. My grandfather was from Sunderland, so I feel like I've come home in a virtual sense. Although my grandmother was a Geordie, so she probably wouldn't see it that way. Mark's given me the introduction there. I've taken the title a bit too literally in my presentation rather than saying it for the euphemism that it is, but that's no bad thing. So I'm speaking on behalf of the Natural Fibre Insulation Group of the ASBP, which is essentially a collaboration of the main natural fibre insulation brands available in the UK. If you want more information on natural fibre insulation after the presentation, then it would be a good idea to maybe go on the ASBP website, and then you can similarly go on the websites of these brands, and there'll be a host of information that you can learn from. We produce a range of learning aids, briefing papers, CPDs, etc., etc. I guess the first question is why, and I guess when you're listening to Nick's presentation at this prior to mine, you can see that timber is just seen as a mainstream construction product, and if you're looking at natural fibre insulation in the major economies of Europe, it accounts for about 10% of the market share. Yet in the UK, it's stubbornly sat at around 0.1%, I think, maybe a bit more if I'm generous. So the question really isn't why natural fibre insulation. The question should be why not natural fibre insulation. And hopefully I'll try to pick up on that as I move through the slides in the presentation. And I think a decent rule of thumb in terms of where you can use natural fibre insulation would be anywhere internally that timber can be used, you could use natural fibres. And they're essentially, certainly the wood fibre insulation is essentially the same thing, and all other natural fibres behave in a very similar way as well. Sort of fibres that would be turned into insulation. You've got cellulose, we've heard about that, jute, wood fibre, straw, hemp, sheep's wool, that's our main brand. Some cotton, flax and sisal. Coir seems to have slipped in under the radar there. Coir is not very good for insulation simply because the fibres are very coarse, but it is an incredibly breathable material, coir. It absorbs a huge amount of moisture and still remains dry. And natural fibre insulation is available as a rigid boards, flexible insulation and also loose fill. And in case of straw bales, obviously. So what does natural fibre do? Well, they buffer heat, efficient insulators, pollutant filters. So for example, sheep's wool can neutralise formaldehyde permanently. Sound absorbers, I think the density and structure of the fibres make them very good at disrupting sound. Carbon store, pretty much all natural fibres will store about 2 kilos of carbon dioxide for every kilo of natural fibre, and they're very efficient humidity buffers. I'll pick up on most of this as the presentation unfolds. In order to really see the benefit of natural fibre insulation, you've got to understand the multiple roles of insulation. So it's not just about obtaining the lowest U value with the thinnest building fabric, which seems to be a rut that we've got into in the UK. And I think it's a rut we're going to have to get out of, once we start looking at alternatives to the usual suspects of materials. You can achieve very good U values with natural fibres. You just have to design a different thickness of building fabric. But that's not a negative. There's lots of positives to that. So when you're looking at the acoustic performance, comfort, durability, everything there, a thicker building fabric is a positive thing. We shouldn't see it as a negative. Just moving on to the properties. Heat buffer. I think when you're looking at wood fibre insulation in particular, the rigid boards. They're very good in terms of phase shift. So essentially what phase shift is, it is trying to make sure that the peaks and troughs of the heat inside a building don't match the peaks and troughs of the heat cycle outside the building. So what you don't want to do in the peak heat of the day is for that heat to be transferred straight into the building. You want that heat to be transferred or dissipated much later in the day when the atmosphere is a lot cooler. And you can see, so what you really want to do is for the peak during the day to be shifted 12 hours forward to the night. And that way, the peak inside and the peak outside are as far apart in a 24-hour cycle as they can get. Wood fibre is very good at that because it has a sort of Goldilocks thermal mass. So the thermal mass is just high enough, but not too high, that it can absorb and release moisture just at the right level. So if you look in here at a roof build up with glass wool, you're looking at a phase shift of 7 hours, far from optimal. Remember I said that 12 is better. We're looking at a U value here of 0.15 for the examples. And then you're looking at an example here where you've got a flexible wood fibre and a 40mm wood fibre on the roof as well. And you're looking at a phase shift of 13 hours, so much closer to the 12-hour optimal. And then if you're looking at a wall example here with a PIR 140mm in the wall, 0.19 U value, again, phase shift of 6.8 hours, far from the optimal of 12. Lo and behold, with flexible wood fibre and a wood fibre board, 12-hour shift. Anyone would think I sold wood fibre for a living, but I don't even. I sell sheets, wool and cellulose and hemp, but got to look at the bigger picture. We're looking at humidity and water activity regulation. Now, water activity is a very new concept to construction, and it's something that people are going to have to come to terms with a bit more because it is now going to be mentioned in Part F, revised Part F of the building regulations. And essentially, water activity is the vapor pressure, the materials, the water vapor pressure the materials exert. And it's the same as relative humidity, which is the water vapor pressure that's exerted in air, air being the material. So in an equilibrium, water activity in materials and relative humidity are the same thing. One's expressed as a fraction and the other's expressed as a percentage, but they're essentially the same thing. And water activity is important because in the same way, relative humidity is important because if you get it too high or too low, you have impact on indoor air quality and the health of the occupants and everything that leads to. Just one other thing on water activity, that is the driving force for moisture in buildings, is the vapor pressure, so it's something that really needs to really increase in people's consciousness. I talk about breathable, natural fibre insulation here, by the way. Breathability is not a substitute for ventilation. And similarly, ventilation is not a substitute for breathability. Now, you will see diagrams which are entirely correct, where you're seeing moisture passing through the building fabric. But what that's signifying is the ability of the building fabric to allow the transport of moisture in a very safe form. So you get the transition between it being bound to the solid, i.e. the fabric, or being as a gas, i.e. water vapor. So the breathable fabric allows the free movement of moisture. It is not a way to remove all the moisture from the building. It's just a way to allow the building to not harbour bottlenecks or means by which water can accumulate and cause damage. So by no means see breathability as a substitute for ventilation or vice versa. How materials, natural fibres breathe, the water essentially sticks to the natural fibre, in this case keratin, but it could equally be cellulose, hemicellulose or lignin. water molecules stick to the fibre like a magnet. When they do, they cease to behave like liquid water, so they are not available to promote deleterious reactions or promote any microbial activity. Again, see these sorption isotherms. First thing to make a sorption isotherm understandable to people is to change the name. I think if we just call this a water moisture behavior curve or something, people will be a bit more palatable. Essentially, all natural materials have water bound to them in 3 ways. You have very tightly bound water that remains there pretty much permanently. And you have very loosely bound water that sort of essentially comes and goes, very transient. But there's an element in the middle, again, back to Goldilocks, where the natural fibres can really buffer a lot of moisture, something in the region of about 10% of their own mass. And what's important is that when the natural fibres hold that water, it is held in a dry form. So if you look at I'm wearing a wool jumper, it's probably got about 13% moisture in it. By the end of this presentation, it'll probably have about 20, but it is still dry to the touch. That's the important thing. Low VOCs, I've got some data here showing thermally bonded wood flex and sheep's wool, all those levels for total VOCs and CMRs and formaldehyde, very low. An example here of sheep's wool, I'm a chemist, so I've got to get a couple of reactions in. So this is the way that wool absorbs and removes formaldehyde very efficiently in what's called a condensation reaction. It's called that because some water is evolved during the process. Acoustic absorption, very, very, very important benefit. Again, I've used sheep's wool as an example here, but I think it's well recognised that wood, both flex and ridges, got a very good acoustic profile, as does blown cellulose. I've only got 20 minutes, so I can only shoehorn so much in. Natural fibre insulation is generally treated with inorganic mineral fire retardants. It's a technically combustible insulation, technically speaking, but its reaction to fire is very different than other insulation materials, and it conforms with Part B of the building regulations and doesn't play a role in the developmental stages. So being used very safely and effectively worldwide for many years. And in fact, I don't know if not many people would be aware of this, but in the United States, blown cellulose insulation accounts for about 20%, 25% of the market. So whereas in the UK that we see natural fibres as some quirky little thing, everywhere else in the world has sort of cottoned on to the fact that these materials and these products have a real benefit, a real role, and there's a lot of technology. And that just because something doesn't look space age doesn't mean it doesn't work well. And thankfully, certainly the students amongst the audience, hopefully will be the generation that specify these products as a matter of routine. Just one last slide that I've got to mention, the ASBP and ourselves, and Back to Earth as well. It's another natural fibre insulation group member. We're part of a research project aimed at sort of looking at waste bedding and incorporating that with natural fibres as well. And essentially the purpose there is to look at all the resources that are available to us and try and find some useful insulation products. And Mark would be glad to hear that I'm actually a minute early. I've given the chair a minute and 20 seconds back. As I say, if anyone wants more information on natural fibre insulation, if they can go on the ASBP website, these are products that certainly you should really be looking to specify as the insulation of choice, well-established technology and first-class performance, providing that you see the multiple rules of insulation and you don't take a one-dimensional view of the products. Thank you.
Thank you very much for that, Mark, including the little bonus time saving. Yeah, we might, yeah, maybe we'll get back on track. But yeah, I just want to echo everything Mark said there, that you know, these wood fibre insulation materials have got an awful lot to offer us in the construction industry, and they're very well suited to helping us to tie in with addressing other climate related matters from their thermal performance side of things, but they can do a lot more than that, as Mark highlighted. We'll move forwards now, if we may, to Justin Peckham, who is the technical sales manager for the ACCSYS axis, talking about modified timber, increasing longevity, basically how to use and specify the products that are available. So Justin, over to you.
Okay. Sorry, Mark, you caught me rather on the hop there. I was expecting someone else to go first.
Have I jumped a step?
Yeah.
Yeah,
Can you
I
see
beg
the
your
screen?
pardon. Must be scrolling too far on my sheet.
Can you see the screen, Mark?
We can, yes, thank you. We'll come back to you, Kevin. Don't worry.
Okay.
I apologise for that. Yeah, so Justin, go for it.
Okay. Thank you, Mark. So, brief introduction. Nick earlier referred to pickling of wood. This is pickling of wood. So it's a bit more scientific than that. It's I'm going to major on a product called a coir today, which is a type of modified wood. I'll touch on another product we have related to that at the end of the slide. But this is a product manufactured by the company I work for, which is called ACCSYS Technologies. And briefly about myself, I've been working with a coir for the last 13 or more years, and I'm responsible for sales in the UK and a few other countries. So what is a coir? A coir is a modified wood, and I like to differentiate in general terms between modified woods here and treated wood. So treated wood, I'm sure you're very familiar with. You impregnate the wood with a biocide. Key point about that is that in so doing, you don't actually change the wood itself. The improved performance comes from the chemical that you put into the wood. So if that chemical breaks down or leaches out over time, you're back to the performance of the wood. However, when you modify woods, like a coir, yes, you put something into the wood, but the purpose of that something is to change or modify the wood, such that the improved performance now comes inherently from the wood. So it's a much more permanent improvement in performance. Another difference is when you treat wood, you're only treating the outer few millimeters. It's what we call an envelope treatment. So you're at risk of exposing unprotected wood if you cut it or profile it. However, with a coir, the modification takes place throughout the profile. So you can cut a coir into all sorts of shapes or joints without risk of exposing unprotected wood. Another difference is that when you treat wood, you're only improving one aspect of performance, that's its durability or rot resistance. When you modify woods, processes such as we use for a coir, you get multiple benefits. So not only do you improve the durability, for example, you generally increase the stability of the wood, which is a key performance benefit as well. And you'll see later in the presentations, there are other benefits deriving from that. There are limitations with the disposal of treated woods. However, because the process we use is non-toxic, then a coir can be recycled in the way that normal untreated wood can be. And indeed, it can be upcycled to the sister product that I'll mention later. Cost-wise, though, treating of wood is significantly cheaper than modification of wood. And you might imagine that with different types of modification, and this is true, there are different cost levels and different performance levels. But generally, modified woods more expensive than treated woods. So honing in on Accoya in a bit more detail, having talked about the concept of modified versus treated, Accoya starts life as a sustainably grown softwood that would not perform very well. And we use this process that scientists call acetylation to modify the wood and improve its performance. So this is akin to pickling the wood. This makes big improvements in the durability, rot resistance, and the stability of the wood. Yet you still have a non-toxic and fully recyclable wood at the end of the process. It's mostly used in outdoor applications. That's because the performance benefits really suit those applications. And to some extent, you're wasting money on those benefits for internal applications. But there are some applications where it is suitable, particularly where you need stability in timber, in internal situations. So a little bit more detail, this is how the process works. More chemical reactions here, I'm afraid, for you. But I draw your attention to the photograph here, bottom right, showing highly magnified softwood cells. And water can sit in any plant in essentially two regions. One is what we call free water in the capillaries or the lumens in the cells. Indeed, in the gaps between the cells. And this water is free to move through the actions of gravity or capillary forces. It could also sit in the cell walls here, and here it is chemically bonded to the wood molecules. Now, water doesn't just seep into the cell walls, it's chemically drawn into the cell walls from the capillaries here. And there are certain chemical groups in the cell wall that do this. And the relevance of all this is that water has different impacts on the wood depending on where it sits. So water in the capillaries will have no impact on the volume of the wood. It doesn't cause swelling and therefore shrinking of wood, nor will it encourage rot fungi. Rot fungi live in the cell walls, and they need water in the cell walls in order to break down and rot the wood. Water in the capillaries can still cause some issues like encouraging surface molds and coating disruption and so on, but the main problems with water are caused by water in the cell wall. And the way that acetylation works is by soaking the wood in a big chamber with something called acetic anhydride, which is like a concentrated form of vinegar. We react the acetic anhydride with the branches on the wood molecules, they're called hydroxyl groups, that are responsible for drawing water from the cell walls, from the capillaries into the cell walls. And we changed these hydroxyl groups into a chemical group that already exists in the cell wall called an acetyl group. And the acetyl groups are inert as far as water is concerned. They don't attract or bond to water molecules. So after the wood has been modified, water finds it very difficult to get into the cell walls of Accoya, and that's how we get the performance benefits. Note that we're not killing the rot fungi here. There's no toxins involved. We're just effectively making the wood indigestible to them. The byproduct of the main byproduct of the process is acetic acid, which incidentally we clean up through condensing columns and we sell on as a raw material to other manufacturers, typically of cleaning liquids for food preparation surfaces. So what are the benefits of this process? The main benefits of Accoya, I've already mentioned, is very durable, very stable. The stability also leads on to being a very good substrate for coatings, resulting in a requirement for less maintenance on other timbers. And there are a number of other benefits there, but we don't have time to go through all of them. So I'm just going to focus on the main ones. So durability, rot resistance. This is a key performance benefit of Accoya. And in the graph here, I've referenced the European standard, EN 350, that attributes what's called a durability class to all natural timbers and indeed to modified and treated woods as well. The durability classes range from 1, the best, to 5, the worst. And with natural timbers, they only relate to the more naturally durable heartwood of the logs, not the more recently grown sapwood, which is in all timbers it is defined as use class, durability class 5, whatever the species. So in the graph here, I've shown that Accoya is a class 1 durability and compared that to other timbers with which you might be more familiar. So oak, for example, this is European oak. Oak has quite a wide range of durability, anything from 2, which is pretty good, to 4, which is not so good. And one of the challenges when you're specifying timbers like oak with a wide range of durability for external applications where durability is key is that it's very difficult to know what quality of wood is going to turn up on site. It could be perfectly suitable. It may not be quite up to the standard you're expecting and not have the service life expectation that you had. So the benefit of Accoya here is that it's not only is it a high durability class, but because we manufacture it under controlled conditions and have a quality control process whereby we can assess the performance of every batch that we produce by a simple chemical process, we can be sure that it's all going to be class 1 durability. And that allows us to give warranties on the performance of the wood, which I'll come to later. Just briefly, whilst on this slide then, there is a means of translating durability classes into expected service life application, depending on the use to which the timber is being put. So this is, there's a British standard here, 8417, that takes the durability class of the wood, looks at the use to which it's put and puts a minimum service life expectation. So what this is saying is you've in an external cladding situation, for example, deemed as use class 3, if you have a timber of class 3 durability or better, like good quality Siberian pine, Siberian larch, you can expect a minimum service life expectancy of 15 years from that. If you use a more durable timber like North American Western Red Cedar, that 15 years goes up to 30 years minimum service life. If you can be sure of using a class 1 durability timber like Accoya, that goes up exponentially to 60 years service life. Now, clearly, these are minimums, and with good design in particular and proper installation, you can get considerably better performance than that. But Accoya is offering you the peace of mind you're going to get those service life expectations, even if there are weaknesses in design. Another big benefit of Accoya is its stability, and the video I'm just going to run shows what acetylation does to the stability of wood. You're looking at 2 pieces of wood here. On the right is radiata pine. This is the species that we start out with. And on the left is acetylated radiata pine, i.e. Accoya. And we're soaking them both in water, and they will both take up water and swell accordingly. And they're going to swell mostly in the vertical plane because of the way the grain has been cut. And we're measuring that movement with these dial gauges up here, measuring the number of millimeters that these pins are pushed out. And then the bottom right, we've got a clock whizzing round. And you can see that after an hour, the natural radiata pine has moved 10 times more than the acetylated version or modified version of that, the Accoya. So that's a considerable improvement in stability. Note that we're not saying that Accoya moves 10 times less than any other wood. Radiata pine is a fast-growing wood, so it's not the most stable wood. But Accoya in our tests has been at least 3 times as stable as any of the woods that we've tested. And that has obvious benefits for some joinery applications, particularly sliding sash windows, bifold doors, and so on, where stability is key. It also has relevance for cladding applications where the wood is going to be a lot less likely to cup and generally distort. And that means you can push the boundaries in terms of design. So, for example, use thinner boards than you would otherwise use, or wider boards, or reduce distance between fixings, or use mitre joints on the corners of buildings, for example. It gives you a bit more flexibility. This slide, incidentally, illustrates a trial from Trada, where they were comparing the relative stability of different timbers in a cladding context. And in this test, under extreme circumstances, they're pushing the materials here to their limits. and they found that Siberian larch moved the most in this trial. Thermal wood, which is another way of modifying wood using heat. That's cheaper than our process, but the performance isn't quite as good, as illustrated here in the distortion. The Koya here was flat against the ruled, and Western red cedar, which is a pretty stable natural timber, was still moving a little bit. I mentioned warranties earlier, so we back our product worldwide with warranties, and in summary, the warranty is for 50 years against rot and excessive movement above ground, and 25 years for the same in contact with or below ground. Now, technically, the cutoff point is the splash zone, which we define as 200 millimeters above a horizontal surface of which rainwater can splash. So anything that is more than 200 millimeters above the ground is 50 years, and anything closer to in contact with or below the ground, or even immersed in or semi-immersed in fresh water, has 25 years warranty. The only situation we don't currently warrant is permanent immersement in salt water. That's nothing to do with the salt, that's to do with the marine borers or shipworms or gribbles that live in salt water, and that's a collective term for groups of mollusks and crustaceans that will bore into wood over time. We're still doing some work in that area, but we don't have sufficient information to make any claims as yet. The third big benefit of Accoya is its stability as a substrate for coatings. And the main reasons that coatings, and I'm talking here not about things like decking stains that sit in the surface of the wood, I'm talking about coatings that at least sit partially on top of the wood, they form a film over the wood. These coatings, the main reason they break down on timber is due to the movement of the timber, shrinking and swelling all the time. And whilst the coatings are designed to move with the wood, there's only so many cycles they'll go through before they start to lose their elasticity and become brittle and break off. And because Accoya does a lot less shrinking and swelling with changes in humidity, the coatings are under a lot less stress, so they last longer. And that's illustrated graphically here by this photograph from a trial from a coatings manufacturer. And this is a south-facing site in Oxfordshire. Same coating systems on 3 different timbers. And as I say, a picture says 1,000 words. And that's down to the stability of the Accoya. So that was on cladding. This is an example on joinery. So this is a window made in Germany, 12 years before this photograph was taken. And this window has been outside for almost all that 12 years. I think there was perhaps best part of 1 year where it was indoors. But apart from that, it's been outside to the exposed to the elements, and you can see the coating is absolutely fine. Just even here, where as part of a coating test, they have scratched the surface from day one, which would generally introduce a weak point to the coating. But even there, it's not developed on the Accoya. So it's a very good substrate for coatings, meaning lower maintenance. Another benefit is that it is a better thermal insulator than natural timbers, and we can quantify that with the lambda value. The lambda value of Accoya is about 8% better than softwoods, and at least 40% better than typical hardwoods. So that's a very useful additional benefit when Accoya is used for joinery applications. The main reason for this, incidentally, is because at any given atmospheric conditions, the Accoya is holding less moisture than unmodified timbers. And of course, moisture is a great conductor of heat. On the sustainability side, I won't dwell on this too long. There's a lot of information for those who are interested on our website in terms of EPDs, LCAs, and so on. But I will just talk briefly about one eco-label credential that we're very proud of, and that's Cradle to Cradle. Not a protocol that's particularly well known over here, I'd say, but it's about the circular economy and reusing materials where possible, using recycled materials to construct, and reducing waste on site, and designing buildings in such a way that the materials embodied in them can be recycled at end of life. And materials are assessed under 5 main criteria for their suitability for this protocol. And Accoya is one of only a handful of materials worldwide that has achieved a gold rating overall. And a lot of that has to do with its material health and its recyclability and so on. And the fact that it's sequestering a lot of carbon from the atmosphere during its growth and locking it in for many, many years. So one of the problems we have generally in the timber industry, and affects some species more than others, is that despite our best efforts to replant trees take a long time to grow to reach traditional sawmilling maturity. So temperate and tropical hardwoods, for example, take a lot longer to grow than they last, at least externally, in use. However, we're using here trees that are growing very rapidly in plantations in less than 30 years. And with a bit more carbon input, we are converting this into a material that's going to last at least 60 years, even external. So that allows us to regrow the trees more rapidly than they're being used up. So where one might think of using Accoya, most applications are external, so a lot of Accoya is used for external joinery, windows and doors, and even in challenging situations like bifold doors, for example. Cladding is a growing market for Accoya, and it particularly suits the coated cladding market because of the reduced maintenance from it. Decking is not something we've pushed particularly in the UK here because we're focusing on other areas. But for example, almost all the Accoya we sell into Switzerland ends up as decking products. And Accoya can also be used for structural applications and many other applications like planters, street furniture, street lighting and landscaping and so on. And it's particularly used in appropriate for really challenging situations. And we put this one in because the photograph on the right just came through this last week from a colleague. This is a site in the Netherlands, and it's called the Moses Bridge. And it's an interesting concept where the bridge is effectively going through the surface of the water here. The water does travel underneath. This is an old moat from an very old fort in the southwest of the Netherlands, and when they renovated it, they introduced water back into the moat, but there was a footpath going through the moat, so they needed a bridge to get people from one side to the other. And they didn't want to put a conventional bridge in there because there wasn't one from the original fort, so they came across this bridge that gives the effect of walking on the water, going through the water. And the sides of the bridge here are Accoya, and when they're expecting cold weather, frosty weather, they let the water level rise, so it floods the area in the walkway essentially, so that evens out the pressure from the ice when it freezes. It also means that any people skating along that moat don't fall down the hole. But the point here is that Accoya has now been exposed to these extreme conditions, wet, dry, for about 8 years now, and it's still performing very well in this situation. I mentioned at the start that we have a sister product. This is called Tricoya, marketed in this country as Medite Tricoya Extreme, because Medite are making it under license from us. This looks just like MDF, so it's, if you like, the panel version of Accoya, acetylated wood. And it's sold in sheets just 2.4 by 1.2, just like MDF, and in similar thicknesses and so on. But the critical difference here is that the wood fibers are Accoya, so they don't swell and they don't rot like normal wood does. And Medite Tricoya Extreme, like Accoya, has a 50-year warranty outside. And I like this photograph here because it illustrates a little test that, and we encourage people to do this with Accoya and Tricoya, because to many people the claims we make about performance don't seem credible, And the only way that you can convince people sometimes is to give them a sample and go and chuck it in a bucket of water and measure the dimensions before and after, for example. And this guy I know in Norway took this to the extreme. He took a sample here, and these samples are about 50 mil square. And the sample on the back had been in his dishwasher at home for 4.5 years when he showed me this sample. And we put it up against an original sample, and you can see it has swollen very slightly. But you imagine normal MDF in a dishwasher wouldn't last a couple of cycles. This has gone more than 4 years. So it's a good example of the performance of this product. And this is used for often in combination with Accoya in panels indoors, for example, also for cladding panels, screens. You can, one advantage of this, you can cut out all patterns, logos, even writing on a CNC machine and make panels out of it, for example. And fascia boards is another good example of application to this. So in summary, and I might be finishing a little bit before time even here, wood is a great building material. We've heard from other speakers, not just today, but at other times in this series. Wood is a great building material with very good sustainability credentials, and we need to be using more of it in construction. One of the reasons we don't is that it has some limitations, particularly in external applications, and people are concerned about service life and maintenance. Traditional ways of improving the service life of timber generally involve toxic chemicals. What acetylation does through Accoya and Tricoya is offer a sustainable, non-toxic way of significantly improving the performance of the wood. So allowing it to be used more extensively and in different situations where it wouldn't otherwise be used. And we're seeing both products being used not just as a substitute for other timbers, but as a substitute for more carbon intensive man-made materials, even for things like concrete, steel or aluminium. And perhaps goes without saying, but there's a lot more information on our website for those who are interested. So Mark, that's enough from me.
Justin, thank you very much for that very enlightening talk about Accoya, a product that I've heard about in different circles, but never to such technical to such a technical level before. Okay, so I'll pass over now to Kevin Underwood from the British Woodworking Federation. Kevin is talking about internal and external joinery in all its detail for windows, doors, stairs and flooring. Kevin.
Sorry, I was muted and then I had to come back to share my screen. Okay, right. Yes, Kevin Underwood, Technical Director of the British Woodworking Federation. I represent the woodworking industry and provide technical support to our members, but I'm also chairman of B5381, which is the standards committee at BSI that deals with window and door standards. Also participate in B208, which is the committee that works with stairs. And I'm also on the European committees for both those products. So the presentation today was asked to look at windows, internal, external doors, flooring and staircases. So that's quite a wide range of products to cover in one presentation. So apologise if this is a bit of a flash through the characteristics. But I thought I'd start by looking at some of the materials properties very slightly, and then move on to base the presentation on the European product standards. So I think that the UK standards mirror the European standards now, and the European standards give a good overview of all the characteristics that are expected of these products. So I'll start with EPDs, and I'm surprised that so far today, I'm not sure if EPD has been mentioned. I'm not doing the presentation, sorry. Sorry, because I just
Your,
BSEN 15804 or Kevin Underwood.
You can see Kevin Underwood. You might just need to press on the bottom left-hand corner of your screen, and then your back and forward might work.
I'm not sure. Sorry. Bottom left. No.
Are you clicking on the Zoom rather than the PowerPoint?
I'm clicking on the PowerPoint.
Okay.
Let's try sharing again. Hang on. Sorry about this.
We can see the screen. We can see your presentation.
You can see the first slide, but not the second slide in the presentation. It didn't change.
Maybe try quitting out of the presentation. Unshare, so to speak. Try again.
Not doing it.
So while Kevin's just addressing this little technical issue, I think EPDs did crop up once or twice. So they are environmental performance declarations, and they're a very useful way of tracking the environmental credentials of particular products right across the entire construction industry. But obviously we've got them in the context of timber products as well. How are you getting on, Kevin?
No, still not there.
Oh, there we go. See a new slide. Oh, no, that's a worktop desktop.
Yeah. Okay. I'm just seeing presenters, comments.
So any particular questions from the audience at the moment that Kevin's just tidying up some of these loose ends? Any particular questions that we could start to have a little look at? I'm just scrolling through. Yeah. How does Accoya perform in above ground maritime climates? Is one of the queries. Justin, if you want to dive in with your microphone for a moment.
I don't see that one on my chat. But anyway, maritime climates, yes, very well. Examples. I remember going to Guernsey many years ago to talk to an architect there, and he'd seen Accoya being used in all sorts of countries around the world. Was very concerned. As almost every country we go to, people say, "Yeah, I see it works there, but we're different here." And Guernsey's, it was pointed out to me that there are, for days on end, sometimes it gets shrouded in sea mist and is really challenging for timber products. But that was a good few years ago. That was a particularly large residential property, and it's performed really well. And they've been back and bought more windows and some decking for the property since. And it's now used extensively in the Channel Islands, I have to say.
Very good. Okay, Kevin.
Right.
Okay.
People seeing 15804 now.
No, you just need to share your screen.
I'm trying.
Shall we skip on to the presentation by Janet while you just have a little look at your technical?
Well, I wouldn't know.
You need to do a reboot.
Shall I share screen and you just say forward? That's going to be awkward or difficult.
Well, I just.
Here it comes.
Yeah, we can see your screen. We can see the PowerPoint.
Yeah, but that's the wrong screen. That one.
There we go.
Right.
Go forwards and backwards.
No, not changing. Go back to this. You're seeing 17213.
Correct.
And 15804?
Correct.
Right, okay, sorry, that seems to be it then, thank you. Shall I carry on?
Yes, please.
Right, so we were on EPDs, I think. Let's just put that aside. So the products I'll be talking about can all have EPDs undertaken in accordance with the product category rules for construction products 15804. However, specifically for windows and doors, we have the product category rules for windows and doors, which sets more detail on how those EPDs should be constructed. Particularly, this helps us with choosing the functional unit and the life cycle stages that should be worked on. And it helps to standardize the way that the EPD is declared, which is important when comparing products. That they should all be based on the same life cycle stages, cover the same type of product, and report on the same functional unit. Now, when we look at the materials used, and previous speakers have touched quite a lot on this, we need to ensure for these joinery products that we're using legal and sustainable timbers. And having formally left the EU and passed over the transition period on the 31st of December, we're now controlled by UK versions of the previous EU regulations. So we have to operate under the UK timber regulations, and we have UK Fleg T to consider, but at the moment they are as they were under the European stage, although we are now a third country in relation to importing timbers from the EU. We also should look at sustainability and chain of custody. So the two chain of custody schemes that our members tend to work with are PEFC and FSC. Now, all the products, well, most of the products I'll be talking about, not all the products, will be working towards some form of conformity assessment. Now, the Office of Product Safety and Standards and MHCLG have recently published a list of designated UK standards, which is pulling across the existing European harmonised standards onto the UK statute books. And for the products I'm talking about, these are going to be BSEN 14342 for wood flooring, EN 14351 for windows and doors. There'll be also EN 14351 Part 2 for internal doors, EN 16034 for fire performance of doors and windows. But for staircases, there are no designated standards, so we don't have to consider conformity marking, although I will talk about the characteristics that are covered for stairs under their product standard, which isn't a harmonised standard or a designated standard. So as I said, it doesn't lead to conformity marking. So for wood flooring, this is the finished floor rather than structural floor. We're looking at EN 14342. Now this covers multitude of different types of flooring, as you can see there: parquet, laminated flooring, standard cut timber floors, and if you're because of all these, we describe them in terminology standard that just helps to figure out which type of flooring fits under which category. However, for the characteristics of these floors types, they are all the same. So under 14342 2013, the key characteristics of wood flooring that we're interested in are dimensional characteristics, reaction to fire, so that's the ability of the timber to catch fire and pass flame throughout the building, release of dangerous substances, which is important when we're looking at the effects on indoor air quality, breaking strength, so if it's put across two joists, how much load can it bear before breaking, slip resistance, thermal properties which are used as part of an insulation system, and the biological durability, which Justin has just gone into detail on. For external door sets and windows, and for internal doors, surprisingly, the characteristics covered 14351 Part 1 and 16034 for fire performance. Now, I added in internal doors because I'm involved in a project where we're looking at product data templates for transferring joinery product information digitally. And the door set characteristics can be covered on one template because it's really just the weather performance, which is the key difference between the internal and external standards. So if we include all the weather characteristics, then that covers all the characteristics for internal and external doors. So those characteristics for windows and doors come like this. Now, the ones in green are the essential characteristics, the ones that would have to be declared on a declaration of performance if they were required by the national regulation, or now the UK regulation. And what we have for these products are resistance to wind load. That's an external product. They have to resist the wind pressure, not be damaged, not dislodge, not break the glass, etc. They need to be watertight to suit the local conditions. Again, the measure of the emission of dangerous substances, but only in consideration for its effect on indoor air quality. Impact resistance, if it's a glazed door and can lead to an injury risk. Load bearing capacity of safety devices. So, for example, that's where a restrictor is used on a window to limit the maximum opening size to prevent people from falling out. And there is a load bearing requirement for those components. And there's a threshold value. So there is a minimum load that has to be sustained by any product that's fitted with a load bearing device, a safety device. The height and width of door sets should be measured. The ability to release to open is a characteristic of door sets that are on escape routes, and that's the push pad or push bar type doors where they, in the event of a fire or the need to escape from a building, they have to open with a simple operation, and that has to be assessed as part of the product conformity assessment. There's an evaluation of acoustic performance. So if you're controlling the internal noise levels from external sources, then the sound attenuation needs to be measured and the contribution to the reduction in sound evaluated. There's thermal transmittance, U value, and the measure of radiation properties. So this is where we determine how much solar energy transmittance, so much solar heat gain there can be, and light transmittance, which of course is important for the energy balance of the window, and if looking at the need for the demand for artificial lighting. So moving on, the other characteristics for these doors and windows: air permeability. That's the infiltration of uncontrolled air passing through the window or door set. Operating forces, the loads needed to lock, open, close the door. Mechanical strength, so if the elements of the door or window are able to withstand certain loads. Ventilation, which again was mentioned earlier, is an important under Part F for the building regulations to maintain indoor air quality. Bullet resistance, explosion resistance, which is sometimes called upon. Durability, so resistance to repeated opening and closing. Behavior between two different climates, that's when we can look at the effect of distortion due to, say, a damp, cold climate on one side and a warmer, drier climate on the other, and whether particularly a door leaf would distort under those two conditions. And then burglar resistance, which is becoming more important, and needs to be a consideration in a lot of projects, because people will, in a secure home, will feel safe. And then we have the fire characteristics from 16034. These need to be considered together for product performance. So we have fire resistance, typical product of a fire door, characteristic of a fire door, smoke leakage, ability to release to close this time. That's an assessment of the ability of doors on, say, cross corridor doors to close when they're released from a hold open mechanism, that they must close and prevent the passage of fire and smoke through the corridor as they're intended to do. And for a self-closing fire door, there's an assessment of self-closing. Okay. So we move on, and said that staircases weren't covered by a harmonised standard, but we do have a European standard that covers the characteristics of staircases, and this is EN 15604. However, to mirror that in the UK, the key standards for stairs are BS 5395 Part 1, 585, BS 585 Part 1, and BS 585 Part 2. Now, these are set levels of performance and expectation for staircases, but they cover the same characteristics that are covered in the European standard 15644. So I'll just look at those characteristics and then run through them in light detail. So the characteristics for stairs in 15644, as with the timber Justin mentioned earlier, we have to look at climatic conditions. So this is the use class that the stairs are going to be required to perform. So class 3 for external above ground, they tend to be, or class 2, where they could be subject to high humidity and occasional wetting, and that would change the choice of materials. Also, the durability, the ability of the products to withstand wear would depend on the level of traffic that they're expected to cope with. So stair in a high use area, say in a school or office building, would have to have higher levels of durability than a single home stair that's used occasionally by a single family. Comfort is a description of how comfortable people find the stairs to use, whether they have to raise their feet between treads. If there's a high rise, they may find themselves having to take a high step each time, which is uncomfortable. If there's a deep going, if that's the width of the treads, that could cause people to have to do a long stride to take each step, and that becomes uncomfortable as well. So there is a controlled measure for a comfortable step, and that's used to ensure that the understep and overstep aren't common, and understep and overstep can lead to accidents, slips and falls on the staircase. It's important to measure the load bearing capacity of staircases. The load requirements change for the type of accommodation they're working with. So there's going to be lower loads required for a private stair and higher loads for a common use stair in a public building. We need to consider the stability and stiffness of the stair. So that's so that it does. We don't want ultimate limit state to be a failure of any component, but we want an operational limit so that they feel stiff, they don't sag, and they don't resonate as people are doing regular steps up the stair. So we have a number of characteristics to consider, and it tends to mean that the size of components producing the structural stability of the stair are greater than is just required for the static load bearing requirements. The resistance of the fixings just ensures that what the stair is, the fixings that the stair is installed using, and any screws, bolts that are used to assemble the stair have to not fail in use. They have to provide the support that was required throughout the life of the stair. Resistance to fire for a staircase may sound unusual, but sometimes a stair is used as a separating compartmentation device to separate one compartment of a building to another, or part of fire resisting construction. And in that case, it needs to have a measure of fire resistance. The other one should be reaction to fire. Oh, I've got it there, reaction to fire. And that's the, again, I touched on that earlier, that's the ability of material to spread a flame. And staircases in buildings over 3 stories, common use stairs in buildings over 3 stories, have to be of non-combustible materials, class A1 or A2 under the European system. So that means that most timber, well, in fact, all timbers, I'm not sure of a modified timber that can get A class, it's not possible. There is a certification scheme by BRE that tests the ability of a staircase to withstand a fire until the accelerant in the test chamber is exhausted. And that can be used to test the performance of a stair and prove its suitability for use in medium-rise buildings. But just following the guidance in the approved documents means that timber stairs can't be used on buildings over 3 stories. Hygiene, health and the environment, again, is the measure of emissions to indoor air. And the geometry of the stair covers things such as the length of the stair, the height and width of the stair, so again controlled by building regulations, the minimum and maximum rise and going, and the pitch of the stair. You can't have a stair under approved document K that's more than 42 degrees. We carry on. The overlap is a measurement of the one tread has to overlap the back of the tread below, so there isn't a gap and the possibility of reducing the possibility of falling through. There's limits on the number of rises between landings, again controlled by building regulations. There are limits on the opening sizes in a staircase that prevent people from falling through and prevent children from becoming trapped. Again, in building regulations, we have to look at minimum headroom allowances and recommendations for the dimensions of landings. It should be an area at least as wide as the length, at least as wide as the stair at the top and bottom of each stair. And we also measure slipperiness. So people would feel unsafe using a stair where the surfaces felt slippery, and there's a way of assessing the slipperiness of the materials used to finish the stair. We also go on, handrails are important. Handrails are used by people using the staircase. They can help themselves pull up the stair if they have limited movement. And if someone does slip or trip, they can be used to stable the user of the staircase so they avoid a fall. It's important to get the position of the handrail, the height correct, otherwise it won't be intuitive when someone reaches out to grab hold of the handrail, and they may not be able to stabilize themselves. And the geometry, the section of the handrail is important because it has to provide people with a strong grip, so that if they do need to stop themselves falling on the stair, that they are able to get that firm grip and stop themselves falling. Designs that don't allow a good wraparound grip can tend not to be graspable by people with limited strength in their hands. The balustrades are used for guarding the sides of staircases. Every change of level over 600 has to be guarded in the building regulations as part of the protection from falling. and there are minimum heights given for balustrades dependent on the location and use of the stair. These are based around where the centre of gravity is on most people, so that the centre of gravity doesn't go over the top of the balustrade and causes people to be more vulnerable to falling over. We also have to consider that the design of balustrade should be such that children are discouraged from trying to climb up, because then if they climb the balustrade, they can fall from the balustrade and injure themselves. Tactility and visibility are perhaps derived from Part M of the building regulations for access. This would put surfaces for people with impaired vision, so they can detect, feel when the landings and where the stairs are starting, and be able to detect the nosings on the stairs. And similarly with visibility, nosings and handrails should be distinct from the surrounding building, so that they can easily be picked up by people with limited visibility. And lastly there, safe breakage. Any materials in the stair, and sometimes we're particularly concerned over glass, if it should break in such a way that it doesn't cause injury. In fact, glass shouldn't break, because we have a problem over protection from falling, and shattering glass won't protect someone from falling through. So if it should just crack and fail as if it was laminated glass, and not cause any holes for people to fall through. So that was a quick run through on the key characteristics for a lot of products. Could have a lot more detail, but to cover a wide range of products in a relatively short time, and you can see there's a lot of characteristics for those products. It was the speed and the detail that I had to go through. So thank you for listening, and that's the end.
Thank you very much, Kevin. Yes, you've highlighted a lot of standards that we as architects and other people of the construction industry all have to deal with, and it's fair to say that we never master all of them. We always rely upon each other. Now, I just want to reassure Janet, Sycamore, and Stefano Muscoloni that you're both going to get your chances and your slots. Don't worry, we're not really holding to time and chucking everybody out. So, Janet, if you could please take the helm and do your presentation, please.
I could, but I've been pipped at the post. Oh, there we go. Okay.
So Janet is going to be talking about decking and cladding, designing for robustness, durability, and longevity.
Right, can you see my?
You can indeed.
Can you hear me all right?
So far, so good.
Okay, cool. Hi, everybody. Great to be here. So I'm going to skip you through some of the key considerations to take into account on the subject of timber cladding and timber decking. Points that will help maximise the performance of the timber, because longer lasting timber locks in carbon for longer. So that's the theory. First of all, introduce you to the team very quickly. There's myself and Caroline running the day-to-day operations at the Timber Decking and Cladding Association. Barbara's our ace graphic designer and marketer, and I'm not just saying that because she's in the audience today. She's fab. The chairman, Steve Young. Nick's our head auditor, chief auditor. And then we've got Dr. Ivor Davis, who I specifically want to mention because he's our technical advisor on timber cladding, and he's red hot on the subject of cladding. He's ex-Napier University, and he now works as the senior lecturer in the graduate school at the Centre for Alternative Technology, also known as CAT, in Mid Wales. He's the author of BS 8605, Part 1, the code of the specification standard, and he's currently writing the new cladding manual for Trada. So he's a bit of a genius when it comes to cladding, and we're very fortunate to have Fibre as our technical advisor at the TDCA. So we're an advisory body, and we support the timber decking and cladding industry. We're funded by our members, and we're made up of like-minded companies who are quality conscious and want to stand up for quality. And this is our principal objective: to promote awareness of and demand for quality timber decks, associated landscape structures, and external timber cladding. The message is quite simple: choose the right materials, design them well, install them well, look after them, and you'll get a durable product. So that's it put really simply. So let's jump right into cladding then to start off with, and mention the Timber Cladding Handbook. This is probably the most useful resource that we've given you access to through Tabitha. It's a 48-page document, and it provides clear and concise, relevant information about material choice, design, regulations, installation, and it's aimed at the specifiers, designers, and users of cladding. So this is a brand new document, and it's, as I said, it's probably the most useful resource that you'll get from us for this project that you're working on, this competition. Some of the key considerations with timber cladding. So the timber cladding is in the wet zone of the external wall. It's fitted onto battens over a drained and ventilated cavity, and it's drained, ventilated top and bottom of that cavity. And then there's a breather layer that separates the dry and wet zones. So if the cladding's in horizontal orientation, you just have vertical battens, but for vertical orientation cladding boards, you require the use of a counter batten to maintain that ventilated drain cavity at the back. The batten size generally dictates the thickness of the cavity, but it could in theory go down to about 6 millimeters. There's been a lot of research on the moisture and in the cavity and how it affects the cladding. But the decking at the back, the counter batten will be at least 38 millimeters thick, so that's going to dictate the depth of your cavity. You fit vermin mesh to all openings, so at the top and bottom ventilation openings, you'd have vermin mesh to prevent large insects and rodents gaining access. You need to accommodate for the natural movement of the timber within the design, unless you're using a coir, as we've heard, that's less so, that doesn't move very much. The guidance is to install at 16 plus or minus 4% moisture content. Use through fixing at quarter points as being the best way to fix with appropriate fixings. A lot of the problems that we see that occur with timber cladding when it's installed is the fixings are a contributing factor. So it's important to use fixings specially designed for outdoor use and cladding use. And then minimise the risk of flame spread with cavity barriers. So you can use for the vertical barriers, you can just use a 38mm minimum thick piece of wood. For horizontal cavity barriers, you need to use an intumescent strip, which is fitted between the battens, and that's activated by heat. So in the event of a fire, it would expand and close up that cavity. So that's just a few pointers. That's by no means everything. If you look at the book, that goes through most things, and then it points to the Trada manual, which is a more detailed resource, but that's unfortunately not available as yet. That'll be later this year. So the different profiles and orientation, this allows you to, gives you some design flexibility in what you want to achieve. So these are the categories of profile in BS 8461605. So you've got tongue and groove, rectangular boards which go in a board on board orientation, feather edge, shiplap, and parallelogram, which is an open jointed structure. And this table shows you how you can use those boards in what orientation. So if you're looking at horizontal orientation of the board, you can use most of those types of cladding, and vertical less so, and then for diagonal orientation you could only use a tongue and groove board. And then this table also gives you details about thickness and width of board. So tongue and groove, you want to really be restricting yourself to 120, 125 millimeters wide for the board. But if you're using a Koya, they do a board up to 195 millimeter wide because of the movement characteristics of that material. But typically all the rest are 75 to 150 millimeters wide. And the width to thickness ratio is 4 to 6 times. The width is 4 to 6 times board thickness generally, unless you've got, as I said, a small movement timber like a Koya. And you can use lower than that, but you need to bear in mind that that's going to impact on the cost and the installation time. So if you've got very small boards, it'll take longer. Then allowing for the natural movement, there's been a little bit touched on about the moisture movement of timber, which occurs generally across the grain and not along it. And you can accommodate for that movement. And particularly with tongue and groove profiles, it's appropriate because they're not as forgiving. If it's a shiplap, it's overlapping, so the movement can just occur across the shiplap. But tongue and groove, you need to make sure there's a movement gap there relative to the board width, and that the tongue width and thickness is sufficient, so you don't get that disengaging with the movement of timber, and everything stays nice and secure and in place. So looking at some of the options in terms of species, you've got softwood options, they're in the orangey brown colour, hardwood options in the blue colour, and then modified wood options in the grey colour. And this has been mentioned as well before, the durability class, which is assigned to the commercial species that we have access to, which is in BSEN 350. The 2016 version, the most recent. So it categorises them from 1 to 5, 1 being the most durable and 5 being the least durable. And then we also have classes of movement too. So for cladding, we're using small and medium movement type species. And then I just didn't mention this earlier about these durability classes being then have an associated service life, and I've put an asterisk against the softwood ones there for the service life, just to remind me to say that these need to be treated in order to extend the service life, so they generally be preservative treated. Larch perhaps less so, because there's a lot of people use larch untreated. But you can get typically 15, 30 or 60 years of service life with any of these products. So the hardwoods tend to last longer, and as you can see, the modified timber species, you're looking at 60 years in a cladding end use. These durability classifications relate to the heartwood of the timber only, which is the central core of the wood, and the external core, outside core part of the wood is the sapwood. And that's not durable for all species. So if you've got a durable species and you're relying on that natural durability, you need to minimise or eliminate the sapwood. And if there is any sapwood there, you would put it on the reverse. It would be on the reverse face, but mostly it would be cut out of a durable species. So just some projects, just showing some different types of cladding, just to give some inspiration. So the one on the left, Western Red Cedar, it's a nice clear grade, and no knots in vertical orientation, and at the bottom there's the company that supplied the wood to this project. That's a really beautiful one. Example of British larch in vertical orientation from BSW Timber. Then another one with Western Red Cedar in both vertical and horizontal orientation. Abodo, this is another modified species, it's thermally modified, and that's from Glenarmon Timber in vertical orientation. And then the wonderful coated coated Accoya cladding in horizontal orientation from ACCSYS there on the right. And then Accoya with Sushugiban, which is an ancient Japanese technique, which chars the surface of the wood to give it this nice dark colour. It is a surface finish rather than adding to the durability of the product. And then on the right, we've got aero timber or aero cladding, which is it's chemically treated wood, but it's got a nice sort of cream type finish, and it comes in lots of different colours. Moving on to decking, I haven't got a timber decking handbook to share with you, unfortunately, because that's only just we're only just writing that at the moment. But we've got a more detailed publication, the Trada decking timber decking manual, which I think you might have access to through Tabitha. Maybe she can confirm that. But that's the sets the standards for timber decking and what to use and how to install it. So some of the key considerations for decking, some of them are similar to cladding, because we're using the same material, same sort of principles in a way. So you need to use timber types that are suitable for exterior use, obviously, that are durable enough to be used outdoors. The substructure is as important as the decked surface. It can often be overlooked, but the whole thing is a system and the performance relies on all elements. It's a open, free draining, well ventilated structure, and this helps with the durability. Grooved profiles are designed to channel water away from the deck. It's sometimes misunderstood that people think that it gives slip resistance, but it doesn't. And groove profiles are a quirk of the UK market. Really, everywhere else you tend to get smooth boards, or in Australia, the grooved ones, they fit them with the groove sides down. But in the UK, we fit them with traditionally with the grooved side up. You need to allow for natural movement within the design, install at less than 20% moisture content. Again, use through fixing at quarter points with the appropriate fixings that are designed for use outside and designed for use with timber decking. And then if you like, you can prevent access to the underneath prevent access, it should say, to vermin on low-level decks by using mesh embedded into the ground. It's one of the most popular questions we get asked, actually. Does decking attract vermin? And we've got a blog on that, and the short answer is no, and I won't go into the detail. You can read the blog, but it's quite interesting. So different types of wood, a lot of species are the same as those used in cladding, but there are a few different ones. But typically you've got the broad categories are softwood, hardwood and modified wood, as we've already discussed. Styles smooth, castellated, reeded, grip enhanced, and you can get retrofit grip enhanced strips. You need structural graded timber for the substructure. You can get different visual grades for the appearance of the wood, appearance grades. So you need to check that you're happy with the product you've selected and how it's going to look. And as I said, fixings need to be specialist decking fixings suitable for external use. Some of the lingo on this illustration here. So posts are either embedded into the ground or supported on a pedestal. They support the beams. Beams can either be single or double arrangement. The beams support the joists, and the joists support the decking boards. The deck can be fitted to a property with a wall plate, and then you've got edge joists and front trims. So they're and joist hangers showing there to hang the joists. That's a way of installing the joists. So all the substructure members need to be treated. Typically, it would be a softwood substructure and treated to use class 4. I'll say a bit more about that in a second. In terms of fixing the deck boards, fix them at quarter points, 25% in from the side. If it's a groove deck, put the screw in the bottom of the groove. And then there's just a little illustration there showing you abutting boards and how to detail them. You need to have a 5 to 8 millimetre gap between deck boards, 5 millimetre gap with other with posts, and a 10 millimetre gap with behind the ledger board. So it's all about allowing for the movement by gapping the boards and appropriately. And where you abut the boards, you need an extra batten length, an extra joist or batten length in order to secure it properly. This is a photograph showing you the top of the post. If you angle it, you get better water shedding properties, so that helps with the longevity of the deck. It's just a little trick. So looking at the species then, again, we use the durability classifications from BSEN 350. So if we want very durable, and that's 60-year desired service life, got some options there: Cumaru, Maceran, Duba, Akoya, Abodo, Lignia. And you've got some durable options there, and moderately durable. And then when we get below that, with slightly durable and not durable, we're having to rely on chemical treatment or modification to upgrade the performance and durability of that product. So, as I said, the softwood substructures and softwood decking would be generally treated unless it was a Western red cedar decking, but Western red cedar is quite soft, so it's not very often used for decking. So treatment varies according to where the timber is going to be used. It's important to obtain a certificate to show that it's been treated correctly. And for decking and cladding, we would be using copper-based industrial application of a wood preservative. And these wood preservatives go through a raft of tests. They have to be approved, and they have to put a package of data together: environmental studies, toxicologies. It costs millions of pounds to put these packages together to support the safe use of these products. So they're highly regulated by the Biocidal Products Regulation. And all treatments are in accordance with BS8, 4 and 7, or should be. And this is an illustration, I think Nick Boulton had it there earlier, showing you that treatment does vary according to where the timber is going to be used. And we're interested in use class 3 for deck boards and use class 4 for the substructure. And it's important to get proof that they are treated to the appropriate level. Someone also, I think Justin mentioned this: if you cross-cut your treated timber, you'll expose a internal untreated core, and you need to apply an end grain preservative to that. Again, something which can get missed and should be detailed in your specification to say that that should happen. Slip potential: if there's any chance that the deck that you install isn't going to be maintained effectively, because the secret of having a slip-free, a slip-resistant deck is to keep it clean and free from dirt and debris. If there's any danger that that's not going to be done, then we'd recommend that you'd use grip-enhanced boards. And it's good for areas like steps and ramps and boardwalks and other areas. But in order to, slip prevention methods include designing to avoid standing water, so having a slight fall in the deck so it drains water, using groove boards correctly, using enhanced grip boards, and you can also get slip resistant coatings. So some examples of decking tried to pull up some communal areas that you might consider having a nice area for people to sit and congregate and chat. And this one is it's a pressure treated softwood deck, and it's a place of work, so the people that work in this building get access to that area. And it's built by Deck Builders UK Limited, one of our members. This is a linking pathway from it's a scenic pedestrian link from a housing estate. It's material was supplied by Marley. That's slip resistant material. And then this, I wanted to show you this, which is quite innovative, from one of our members called Gripshaw. And these are bespoke graphic infill boards using the slip resistant aggregate to make designs to illustrate certain things. The one on the left there is the rising path at the Royal Botanic Gardens, and that's a Koya. And the graphic panel gives you information about the taxonomy of the plants that you can see from standing in that location. And then the one on the right is Bearwood at Bristol Zoo, and that's again, that's a pressure treated pine one, and that shows the inserts there are chose to show a design to show the root system around the tree, which is apparently called Steve the tree. So, I mean, apologies if that's really quick. There's a lot more to it than that, but I just wanted to give you some key things to think about. If you want more information, we've supplied information for your use to Tabitha. But you can go to our website. The address is there. You can go to publications and register and get free. If you register there, you can get free publications from us. And the website's also got other information, FAQs, find a supplier section, blogs, case studies, and a whole section split into timber decking and cladding, giving you all the technical information about it. And then I also work for the Wood Protection Association, and they've got a resource centre on their website, which is full of lots of free information about flame retardants, wood preservation and modified wood. So that's really handy as well. So you get a chance, go have a look.
Thanks, Jenna.
So that's a quick zip through.
Right. Okay. Well, thank you for that. I think I'll be passing over to Stefano Muscoloni here to talk about the Rotho Blaas fixings. And I must say that I've used Rotho Blaas fixings at Larch Corner. We used over 2,000 screws to hold the house together, which means it can be completely deconstructed and reused. At least that's what we hope, if it ever gets to that particular point in time. Yeah, so I'm going to be having to say goodbye to everybody, but Stefano, please take it away. Rotho Blaas, fixings galore. Thank you very much. You're muted at the minute. Oh no, you just.
Can you hear me?
Better.
Can you hear me now? Yeah.
Yeah.
So thanks, Mark, for the introduction. I want to say also thanks to Tabitha, because when Tabitha informed us about this challenge, basically we decided in less than 2 seconds. This is something really important for us. Our daily job, our daily work is to promote sustainable construction, to promote timber construction. So, and in particular, this opportunity to promote through the students. We really believe this is a good opportunity. Just a very quick introduction about Rotho Blaas, who we are. Basically, we are an Italian international company. We are leading developer of high technology solution for timber construction, and in particular for mass timber construction. We have 30 years of experience. We are basically all over the world. The main office is in the extreme north of Italy, very close to Austria, so in the Dolomite region. We have 22 warehouses, 22 subsidiaries, 12 warehouses all over the world, and our goal, our everyday work is to export our knowledge, our know-how on timber structure, on timber building. Let's have a look a bit about our product range. So basically, we provide everything you need for a timber construction, for a timber building. The only thing that we don't sell basically is the timber itself. So we deal with different typologies of timber. We have seen a lot today in the different presentations. Our lines basically are fastenings. We are very famous on fastenings. So we are speaking about the engineering part part of a timber structure, so screws, connectors, hidden connectors. Then also the line for high tightness and waterproofing. So basically all the product that we need to have a good indoor comfort in our houses to prevent thermal breaches. Sarah at the beginning spoke about these topics. So all the product related to durability, so membranes, tapes, and so on. Product for soundproofing. Also here is to reduce the impact, the problem of noises and vibration in our timber structures. Is a topic is a not topic at the moment, we can say. Fall protection system and also specialized tools and machine for carpenters. Not so important for our challenge and for the students. Also, it's very important not only all the product we provide for the timber building, timber structure, but it's also the service we provide. We can start for the technical documentation. So why all the designers love to design with Rotho Blaas? Because of course we provide a huge support on technical details, declaration of performance. We provide all the test report, all the information, all the calculation also with the Eurocode, and everything is downloadable from the website. Other service, we have also school in Rotho Blaas. Of course, it's called Rotho School. We provide very high-level courses for architects, designers, builders, installers, and so on. We started to also to export the Rotho School. We had an event, for example, in last year in London. We're gonna have another one next year due to the COVID situation in London as well, through the Institution of Structural Engineers. So these are all service we want to provide to the designer and to students also. Other important service for this challenge is the technical consultings. We have more than 10 people in the headquarters that can easily reply to your questions, so by email or just by phone. So they are always available for any kind of inquiries for designing timber structure or durability of the buildings. Other important tools for the students are a very huge library of technical details. You can download for free, more than 200. Are divided in construction types. So basically are divided in cross-laminating timber structures, glulam structures, LVL, and so on. Another huge section is about the energy efficiency. So you can find there a lot of really important detail on proper design, also with the passive house standard. Very important as useful could be also the our software. Also, the software is absolutely free. You can download it and you can calculate with different fixings, screws or connectors, different kind of connections. Not only timber to timber, but also timbers to steel or timber to panel like OSB and timber. Important as well is also the BIM libraries. This is all for Revit, for ArchiCAD, Tekla, SketchUp, and also other software. So what is our vision? Basically, as I said, our vision is to provide our knowledge, our know-how to the different markets all around the world. We can count off our 30 years experience. So we born exactly in the area where the CLT born. So we were lucky, but we were the first to believe in the mass timber basically. Other very important goal for us is to be easily accessible for all the different countries. So for this reason, we want to be very close with our knowledge, but also with our warehouses, with our services. Other important last thing about our vision is basically the reduction of CO2 emission. As I said, we are promoting everyday use of timber structure, timber building, and we want to be the first to. So we are the first to believe in this. This is our new automated timber warehouse. Is under construction at the moment. Is the first automated timber warehouse in Italy, one of the tallest in Europe. We are, so basically all the structure is made in glulam, LVL, and cross-laminating timber. And the most important thing is we are going to be energy free. So basically in 2025, all the energy we are using, we are going to produce. Okay, so basically also in this new structure, we have 200 kilowatt of photovoltaic system. We have also a solar system, heat pump, so we can create all the energy we need, 100% of the energy we need. Just a bit about the fastenings. So we spoke in the last 2 weeks a lot about timber structure and so on. This is basically how you can connect the structure. So basically how you can fix the structure. So for the fastening, we can divide in screws and connectors. I'm not going to explain in detail screws, otherwise we're gonna stay here another week. But I want to focus this presentation only on modern method of construction, also because we focus on modern method of constructions. So, for example, hybrid structure, nowadays more and more common to see hybrid solution with mass timber. So the combination of steel structure with cross-laminating timber or glulam, or otherwise a concrete core connected with the glulam structure, and so on. Another important method is the prefabrication. We are basically designing always new product to help this new method of construction. Prefabrication, of course, nowadays we tend more to realize the structure in the factory, in the factory than in the building side. Of course, because we can be more precise, we can be more quick, we can save a lot of time in the building side, and we can save also money, we can say. Modular construction. This is another hot topic, we can say. I live in UK since 2016, so it's more or less 5 years. And in the last years, 3-4 years, I have seen a lot of new company dealing with the modular constructions. So not only mass timber, so not only cross-laminating timber, but also mixed, so hybrid, glulam and timber frame, or timber frame, and so on. So this is another line that we are all the time developing. Okay, try to find solution to help these new techniques. Multi-story buildings as well. We are leader in mass timber construction products. So, and nowadays all over the world we are going higher and higher with the timber. In UK we have a different process at the moment. So, but this is not the correct the correct time to speak about this. So we are seeing some difficulties on building with the high level. But basically, yes, we can provide really solution for multi-story building. Another topic in the last here, I would say, is the demountable application. This is because often designers are dealing with life cycle assessment. So for this reason, we started to design and to realize system product that could be demountable, and you can remove at the end of the life of the building. The other line I want to focus a bit, because we spoke about a lot about durability, is the correct product, but also the correct application when we are realizing how our air tightening layer inside the building to avoid the thermal bridges, to have a really energy efficiency in our building, but also the wind tightness layer, so the waterproofing layer outside. So all the product you can see, you can reach a proper durability. You can avoid the condensation in the structure. That is the main issue when we are speaking about humidity, condensation, and so on. Also for durability, the students can find a lot of different details that are really useful, and are really these details are exactly for designers. Okay, so you can find a lot of nice application, and also a lot of details also if you want to follow the passive house standard as well. So we have certificated product with the passive house standard, so you can also find a lot of information here. Soundproofing product as well, as I said before, are product to avoid the propagation of the vibration in the timber structure. That's it. This is my last slide. I hope I have been quick. I want just to give you the contact of all my colleagues in UK. You can contact us whenever you want. You can ask us every kind of topic related to timber structure or timber durability, acoustic, whatever you prefer. We are always available for you. Thank you.
Thank you, Stefano. Fantastic, absolutely fantastic things. Let me just share my screen. And I want to say a huge thank you to tonight's speakers, from Mark and Sarah and Nick and another Mark and Kevin and Richard and Janet and Stefano. I know we've given so much tonight to all our students, so much to get through, which is why we record it and it's available to watch and rewatch. We couldn't do this without our sponsors, the Confederation of Timber Industries, from Accoya, from Rotho Blaas, from Timber Decking and Cladding Association, from the PEFC, from ASBP, from Wood for Good, from BSW. Tomorrow night, we look at health and well-being. And on Thursday night, we look on the timber challenges. And if you've got enough, what's the word I'm looking for, stamina, to come and join us at the pub on Friday, then we would absolutely really love to see you. That's when we get to have a really good old chat and ask lots of questions. So that is the end of evening one on week 3.